The wireless power transfer is a form of wireless transmission of electrical power from the current source to the load without using of wires. Normally, power or electrical current are delivered to the load by a conductor wire that allows current to pass through. But on the other hand, to transfer power without wires, electrical energy is transferred by using the wave frequency. For circuit flow process, first step, we're using 9 volt as power supply for this project. Second step, current is applied to the transistor, which is the function is to convert the direct current signal from the power supply to an alternating current signal and then allow the current through the coil. Third step, the coil at the transmitter will produce an electromagnetic field. Fourth step, the coil at the receiver will receive the electromagnetic field from the transmitter coil and will trigger the transistor to allow electric current through the circuit to complete the process. Last step, the motor will function. In this project, we focus only one application of mechatronics in terms of degrees of freedom robot arm. Nowadays, in industrial now, the robot arm can't rotate 360 degrees because there is a wire barrier limiting the movement of the robot arm, and the wires will likely result in broken wires. Run electric current through a coil with a copper wire in a coil which is in short-range magnetic field. Place a second coil within this field, and then an electric current will flow through it. The magnetic field will transfer this electrical power from one coil to the other coil. This principle is called induction. Induction is what charge a wire electric toothbrush in example. Hold the coil apart and the power transferred receives. The energy then built inside the glass until it's broke. The coils that electricity uses to transfer power wirelessly are magnetic resonators. First, rapidly oscillating electric current is applied to coil at its specific resonance frequency. This will create a magnetic field in the region of the coil. To the second coil, the same resonance frequency is the source and will couple resonating anywhere of the region, and converting the oscillating magnetic field into the electrical current into the second coil. This response is called highly coupled magnetic resonance. By touching the second coil to the device such as the battery of a car or mobile phone, this current can be made to use to work. The source can be meters away from the device to receive power and can deliver power through walls or any metal optical. The power even can be distributed across more than a device, but it's simple tricky physics power transfer wirelessly. Generally speaking, an inductor is a device that stores energy in the form of magnetic fields. Inductors are usually just coils of wires and one of the basic properties of electromagnetism. We only have current flow through a wire that created small magnetic field currents around it. So we coil up a lot of wires to get a stronger magnetic field. An oscillator is something that creates oscillation. Oscillation is just a fancy word for something that moves forward and backward. If a swing moves back and forward, you can say the swing is oscillating. In the context of electrical engineering, the oscillation is weaker about a voltage moving back and forward. An oscillator is a circuit that will generate a back and forward waveform like this. An oscillator not necessarily have to be sine wave. An oscillator also can generate a square wave, triangle wave, Mexican wave, and whatever. What oscillator good for? Oscillator used all the time in electronic design. It used in generating video wave and tone generators, generating counters to keep track of time, and generating clock signals to control the speed of digital processes includes the computer that we're using right now. Function generator is a device which provides a specifiable voltage applied over a specifiable time, such as sine graph, while oscilloscope is an apparatus which is a signal analyzer that usually in the form of voltage versus time graph. By using this, we can obtain the shape of frequency, amplitude, and overall shape. What can we discuss here? This is the shape of graph that we obtain after connect the circuit with oscilloscope and function generator. After set the frequency level and set the voltage, we obtain peak-to-peak sine graph as shown in the figure.